Hello and welcome to a new video about using open source software to generate G-code for your CNC. In this episode I'm going to show you how to use Blender's add-on called FabEX CNC, formerly known as Blender CAM. I will show you how to properly set up a profiling operation, how to select the proper tool bit, how to generate the tabs for holding down the piece to the table, or if you want to use clamps, I will show you how to split the operation into two, like in this example. And one more thing that I will show you is to make several passes to clear much more surface around the object that you are cutting. This is a situation that I have encountered in one of my older videos, the one about creating threaded lid box in FreeCAD. I had to make several operations to set for each of them an extra offset. In Blender, in FabEX CNC, you can simply set a number of passes and the distance between the toolpath and you will have everything ready. So let's get started. I will delete all the operations and I will show you from start to finish how to generate various types of profiling to get the proper results as fast as possible. Before moving on, of course, I want to thank everybody for supporting me through subscribing to my YouTube page, liking the videos, commenting on them, and of course, a special thanks for everybody that's supporting me financially through my Patreon page. So the first operation that I'll show you is a simple operation, just setting up a profiling with a proper tool bit, the proper step down, the proper speeds. For that, of course, you have to have the FabEX CNC add-on installed. If you don't know how to install it, check out this video. You will find there at the beginning a complete guide to install the new plugin, the FabEX CNC plugin in Blender 4.3. This is the version that I'm using now. If there will be changes in the future, I will make an update in another video about how to set everything up and I will post it in the description of this video. So let's get started. I have a simple rectangular object here. I want to cut its outline. How do I do that? First go to the render tab and change the render engine from Eve to FabEX CNC. After that, select the object and in the operations drop down, click on the plus button. This will create a new operation and here in the CNC tab you will find all the settings for the operation. If you cannot find this panel, of course you can toggle it on and off with the N key on your keyboard. So let's set everything up. The default strategy for any operation that you create using FabEX CNC, of course, except if you are using any of the presets, but the default type of operation is going to be a profile. I'm not going to change that. Let's set everything for the cutout. The cut will be, of course, on the outside. In this situation, if I have a circle, a cutout circle in the middle, I will select inside. I won't leave any skin for now. I will show you in the end how to leave a skin and to remove it with the entire cutting height of the tool bit, and this way you will get a much better result. So everything here is going to be left just as is. The default values work okay. So let's scroll down to the operation area. Here I have to change something. The object, let's go to the item tab. The object is 9.9 millimeters high. So going back to the CNC tab and scrolling to the operation area, I have to set a start depth of 9.9 millimeters. A safe height of 10 millimeters is quite small. I want the cutter head to be raised a little bit more to have some clearance, so I will use a safe height of 20 millimeters and I'm going to use a 6 millimeter tool bit. A safe step down would be 3 millimeters, half of the tool bit diameter. Here it is not called step down, it is called layers, but it has the same meaning, and I will set a layer height of 3 millimeters. Let's scroll further down. Here at the cutter you can see I have already selected the end cylinder 6 millimeters tool bit, which would be great. Just go on and continue with the operation, but if I double check here, I have a diameter, a set diameter of 3 millimeters. This is definitely not what I want. I can either change diameter from here or select again the 6 millimeters end mill from the list and everything has changed. Scrolling down to the feed rate, I have some default values which should be different because in the CAM panel here on the right, for my machine I have different feed rates and spindle speed setup, but for now FabEX CNC doesn't take them into account, so I have to manually change them each time for each operation. It's kind of annoying, but it's not a deal breaker. Let's set also the spindle speed and the plunge speed, which is the vertical feed speed and is represented as a percentage of the horizontal feed rate, the one that we've set above. So I will use 100% plunge speed. I want them to be both equal to 3500 millimeters per minute. The next tab, the operation G-code, which can have additional options. It's going to be useful especially for this option output trailer, where I place an M02 command, which means stop the machine after the operation is ready. Otherwise the spindle will keep spinning and you have to turn it off manually. You have several other options here, the dust collector, the hold down, the mist, but those are not available on my machine, so I won't be using them. The movement, I will leave it as a climb cut. Depending on the material, a climb cut will leave a better result than a conventional cut, or sometimes the climb cut will be worse than the conventional. It depends on the material. You can check my other videos to know when to use each of these two types of cutting. In order to correctly calculate the climb or the conventional, you also have to make sure the cutter spinning direction is the one that applies to your machine. All these other options are perfectly as they are, the default values. Now we can move to the right panel and click on the calculate path and export G-code button, which will only calculate the path, won't export the G-code. As you can see, almost instantly I have the correct toolpath generated. I can now click on the export G-code button and I will have the file ready to move to the machine and cut the object that I want. This is the basic of creating a profiling operation in Blender. No matter the shape, it will take its footprint, its projection on the XY plane, and will make a profiling operation out of that. But what if I have several pieces and I want all of them cut in a single operation? It's pretty simple. If I select the operation here in the operations tab, make sure you don't select the operations in the chains tab if you have chains created. So make sure the operation is selected, scroll down, and here instead of data source object, I will select collection of objects, but I don't have that collection yet. I'm going to use cube and cube 002. So let's enlarge this a little bit, right click here, select new collection, and I will call it parts to be cut. And let's move the cube inside this collection and the cube 002, the one that we have already created a toolpath for. And I'm going to hide this toolpath that has been generated in order to be easier to view everything. And now if I scroll down again to the operation, here below data source I have a collection. I will select the collection that I have just created, parts to be cut. And now let's check what happens with the settings that we have already set for this piece here. Click on the calculate path. As you can see, everything works okay except the height. The starting height is the same that I have set for this object, but this object is a little bit taller. So let's go to the item, check it, Z value is 22 millimeters. Let's go back to the operation, to the CNC tab, and let's change the start to 22.1 millimeters. This will show an error because the safe height is lower than the maximum height of the operation, so we have to also change the safe height. Let's set it to 30, and now everything is okay. Let's click on the calculate path button. Of course, it will use the same height for all the objects, and even though this might seem annoying at first, if you think about it, you won't be cutting several pieces out of different materials. You will cut them from a single piece, so it will have the exact same height no matter what you need to get in the end. So using a single starting height is not such a big deal in this situation. And if you have a very fancy CNC machine with a vacuum table, this is all you need to do. You can export the G-code and make the actual milling. But if you are like me and have a homemade CNC, you don't have a vacuum table, you will have to somehow hold the pieces to the table. The easiest way to do that is using tabs, small pieces of material that are going to be cut, and will hold the cut material to the rest of the sheet. After making the cuts on the CNC, I can cut them using a handsaw and everything will be okay. How to set that in Blender in FabEX CNC? Well, it's very easy. Here in the operation setup, just below the cutout, I have this option, which is bridges. And I'm going to set a width of 15 millimeters and a height of 5 millimeters. I also have to set a collection here, but I'm not going to do that. I'm going to click on this button, which is auto generate. It will create the collection for me and try to correctly position all the bridges. Let's see how it works. If it does a good job, click on the button and you can see the collection here, bridges for this operation. It also has the name of the operation. It generated 8 bridges and you can see them as these little rectangles here. nothing has changed for now for the operation because I still have to calculate the path. And now when clicking the calculate path button, you can see that everything is exactly as it should. If I don't like the position of a bridge, I can simply select the rectangle that represents the area to be avoided, select the move option, the move button, and just drag it around, making sure to keep the Z exactly as it is. Now let's calculate it again, and I have an error here. That is because the operation has a little bug. You can see here something remaining for all the bridges. This is an object that should be deleted after it's a temporary object created by the script that calculates the operation when using bridges. Unfortunately, it forgets to delete it, so I have to manually cut this curve and now calculate the path again, and everything is just as it should be. Again, the object is here. Try to remember to delete it immediately after creating the operation, after calculating the path, in order to avoid any other errors that might show up later and you might forget what it is about and struggle to realize what happens. And here you can see the new bridge exactly where I moved it. So it's a very easy way to generate these bridges, to move them around, to use them as you like in order to get the result that you want. But there are situations when I like to hold the piece to the table using clamps and place them on one side, cut the other sides, then hold the piece with other clamps on those already cut sides, and finally cut the side that I avoided at the beginning. In FreeCAD I would select the edges of the object. In Blender I cannot do that, so I have to figure out a way how to do that. In order to do that, I want to have a projection of this object, and I will scroll down to the curve tools and click on the silhouette offset button. Here I will use an offset of 3 mm, which is half of the tool diameter. If I'm going to use a 10 mm tool bit, I'm going to set an offset of 5 mm, and all the other options I will leave them just as they are. Leave curve open, corner round, and align to world XY. Click on the OK button and you can see here highlighted in white the outline, which is not the actual toolpath for now. This is just a curve that I'm going to use in order to split the operation into two. It's a little bit more complicated, but once you get used to the workflow, you will realize that it has some huge advantages compared to other methods of doing this. I'm going to hide this object for now in order to be easier to see. So I have this offset curve. This is the exact path that the toolbit should follow. And before creating the operation, I'm going to select it, make sure I'm with the mouse over the object, somewhere in the view, a 3D viewport, press on the tab key to enter edit mode, and now I will rotate it a little bit and select all these points here, click on the delete button and select segments. And I have removed the part of the offset curve that I don't want to be cut in the initial operation. I want to have two operations, one to cut these three sides and one to cut the remaining parts. Does it really matter how much I remove if I forget some points? No, it doesn't, and I will show you in just a couple of moments why. Now let's go and create, with a line selected, create a new operation, and again the strategy is going to be profile. I will change the cut from outside to online. This means the center of the toolbit will follow exactly this line. Now let's set all the other options. I'm going to show the object a little bit to see the total height. It is 33.5 millimeters. So let's go back to the operation, scroll down to the safe height. I'm going to use a 40 millimeter safe height, the start of 33.5, layers set to 3 millimeters. Again, change the diameter or select the tool bit from the drop down. This time I'm going to change the diameter, change the feed rate and the spindle speed, also the plunge speed, the vertical feed rate, and make sure I check the output trailer. Now I can click on the calculate path and export G-code, and as you can see, it has created the toolpath exactly as I want, avoiding this point here where I'm going to have the clamps. If I take a look at the way the cutter head will move, I realize that I should probably use a much larger safe height in order to be able to fit a clamp here. So let's change it to 55 and calculate the path again. Now the clamps should probably fit okay here. And now how do I mill the remaining of the object? How do I cut this line here? For that I'm going to select the cube again, make again a silhouette offset with the same settings, and I will hide some of these objects and for certain reason it moved everything inside this collection. I don't want that, so let's enlarge this a little bit, create a new collection, and I'm going to call it split operation. So any object that is created is going to be placed in the last created collection, which is not a good thing because this collection was supposed to have only these two objects that I want to cut and their bridges. So I will move this to the split operation, the offset line, the second offset line. So I only have the toolpath, the bridges, and the two cubes here in this collection, and I should also move the cube into the split operation. Okay, so now I can hide this. I can also hide the toolpath, and I have these two objects. The second one is not really easily visible because it is just below the first one. How do I select only the part that I haven't selected in the first operation? So I will first select this object, the one that doesn't have the entire profile, then hold Ctrl and select the first one, select curve boolean, change the type to difference if it has a different value, click on the OK button. For a certain reason it's in the bridges parts to be cut group. Let's just move them around and move it to the split operation. It's almost exactly what I want except this line here. So let's rotate the viewport. It will automatically try to close the curve at the end. So press the tab button to enter edit mode. Select the lowest point here in this corner. Zoom out, zoom in the other corner. And holding Ctrl down, select this other point. Now press delete, select segments, press tab to exit edit mode, and as you can see I have the initial curve, the one surrounding the object, split into two perfectly matching objects because I used difference, a boolean, not manually trying to modify the points or anything like this. And now I will just copy the operation for these three edges. Click on the copy operation button here. One thing that it doesn't copy is the safe height, so let's change it to 55 millimeters. And now I can click on the calculate path button, but sorry, I forgot to change the most important thing, which is the object. It should be the boolean that we have created. Now if I click on the calculate path, you can see that now I have the second part. Let's turn the object's visibility on, the first, and again the path is in the wrong group, so I have to move it. But now, as you can see, I have the objects cut out, split into two operations. The first one, I can hold the clamps here. After making this operation, I can move the clamps and cut the remaining part. Everything should be exactly as I want, and I should have the object cut perfectly. And now I still have one object that I need to cut, which is this cylinder. I use the cylinder especially because I had this problem when cutting a cylinder out of a larger piece of wood, and I had to fit a quite wide tool bit after that in order to mill a thread for a box that I was making. You can see this video on my channel. Well, I had to make several passes to clear some material outside of the profiling operation in order to be able to fit that large tool bit. In FreeCAD I solved it making several operations with an extra offset. In Blender I have a much nicer option. So let's select the cylinder, let's create a new operation, and let's set everything up. So I'm going to leave the strategy again as profile, cut on the outside, and change outlines count from 1 to 4. When changing it from 1, you can see that I have several options new here. Inside out means it will first cut the closer line, then move outwards. If I select outside in, it will change direction, of course. I will set a toolpath distance of 6 millimeters, exactly the diameter of the tool bit. I just want to remove material. I don't want a smooth surface, so that doesn't matter. Now let's scroll down to the operation area. Again, I have to move to the item to see the total height, which is 25 millimeters. So I will use a safe height of 30 millimeters and the operation depth start of 25 millimeters. Change the layers to 3 millimeters and select the proper tool bit again. Change the feed rate, the spindle speed, and the plunge speed. Now I can click on the calculate path and export G-code. You can see the great thing about this option here about the outlines count. Now I can remove as much material as I want to in just one operation. Changing the direction from inside out to outside in will first mill this line and then move inwards. With the option that I have selected, it will first cut the outline of the object and then move outwards to clear the material. But what if I want to use some bridges for this operation? So let's select the bridges. Let's change their width to 20 millimeters and the height of 5 millimeters. Now click on the auto generate button. Again, it created the group in the wrong place, so move it to split operation group and click on the calculate path and export G-code button. You can see there is a bug. If I zoom in a little, you can see that the bridges have been taken into account for the first two passes, and then the final two passes are missing the raising of the cutter head to get those bridges. Of course, this makes the bridges useless unless I can do something about it, which is a little bit time consuming if you have several bridges, but it's a good thing that the bridges are generated as curves because I can easily modify them. As you can see, the bridge defines an area where the cutter simply won't cut below a certain height. Just modifying this curve will enlarge the area. Let me show you. Go to the group, select the first bridge, press on the tab button, and I will select these 2 points, move them on the x-axis to enlarge everything, and now the bridge is covering all the passes that I want. I will repeat that for all the 4 bridges. That's what I was telling you, that if you have, let's say, 50 bridges, modifying them is quite annoying, but for now it's the only solution that works. So now I'll modify this one, exit edit mode, select the last one, modify this one too, again exit edit mode, and now let's click again on the calculate path button. As you can see, the bridges are now correctly calculated for all the passes. One thing that is a leftover again is this object, these lines, that I can simply delete, and now everything looks okay on the screen. I can export the operation and everything should be okay. But in the video that I was talking about, I didn't cut all the way through to the bottom. I only cut 80% of the material. I left a small piece of wood on the bottom to hold everything in place. How do I modify the final depth? Because I haven't shown you that. So let's scroll to the operation area, and here where I set the operation depth, below the start option I have a max which is set from the object. So it will go as low as the object goes. What if I want to use something different? I can either choose material if I have a material set, but I don't have for now, or I can choose custom, and let's say I want a 5 millimeters layer remaining. Simply write 5 here, and now let's calculate the path. You can see that there is a 5 millimeters gap here. It won't be cut. One thing that you need to know is again this annoying object, delete it. The bridges will be calculated from the depth that I have set here. So if you want this line here, the final cut of the bridges, to be at 10 millimeters, you don't need to modify the bridge height. You can leave it as 5 because it will add up to the final depth of 5 millimeters. Of course, in this situation, if I leave a bottom layer, I won't be needing the bridges, so I will uncheck this button, click on the calculate path. Now everything is exactly as I want. I will have a layer at the bottom. I will cut everything above with several passes. If I want more passes, I can increase the outlines count number, and Blender together with FabEX CNC will make that for me automatically. It's a huge time saver. I remember that I had to make 6 or 7 operations to set everything up just to get this result. So sum it up, setting a profile operation in Blender together with FabEX CNC is pretty easy, just as in any other software. You have some very powerful tools here because Blender only works with meshes and curves, and FabEX CNC likes curves a lot, so it tends to transform almost anything, or you can transform almost anything into curves. Modifying the curves after that is very easy, as I've shown you with the tabs, with the bridges that have been automatically generated. Enlarging them is a very easy process. Remember that and use that to your advantage. Of course, remember also the object silhouette and the silhouette offset objects that you have here, or the get pocket surfaces, which is a incredibly powerful tool if you are using a lot of STL files and you want to mill them on the CNC. You can check my video about creating pockets in Blender together with FabEX CNC on my channel. Thank you for watching. I hope you learned a lot of useful things in this episode. See you next time for another episode about using open source software to generate G-code for the CNC.